The august member of the Honorable Panel of Critics, Panel Chairperson Dr. Edward Panganiban, Content Panel Professor Renalyn Texon, Technical Panel Dr. Romero Dante Salum, and to our subject teacher, Dr. Darius Alado. A wonderful day to every one of you. On behalf of our advisor, Dr. Jamie Tats Infante Mateo, we are pleased to present to you our proposed project entitled Arduino-based Alternating Current Controller System today, June 1, 2022 via Zoom platform.
Our esteemed panelists, I am Ryan Soxales of BSIT 4-3, the project and software developer, and I live with the principle that life is too short. Let's make the most out of it.
Likewise, I believe that you only live once, but if you do it right, once is enough. I am Mary Grace Aljibaton from BSIT 4-3, the project manager.
The outline of our presentation starts with the rationale, objectives, result and discussion, conclusion, and recommendation.
The traditional cutting of electricity is very time-consuming and not safe for both consumers and line personnel, especially at this current situation of the world, wherein we are all facing pandemic. Many people lost their job and many businesses were closed. A line personnel need to cut electricity line and go one place to another for their job. The process of cutting off electricity may take days or even weeks before they cut the electricity line.
The proponent thought of developing an Arduino-based alternating current control system. Further, this innovation specifically helps Iselco One in cost efficiency in terms of personnel services and reducing the risk of human life loss and health hazard and cost reduction on maintaining electrical lines.
This proposed study aimed to develop an innovative way in the way Iselco One does its management of power line, especially on the imposition of sanctions for their client unpaid use and eliminate the manual tasks in disrupting the supply of electricity to a household. Specifically, it seeks to
First is develop an Arduino-based system, a web-based system that controls the electric line and notify the specific clients for disconnection and reconnection. Second one is develop a prototype that controls the flow of electricity in the targeted household. Third is test the functionality of the system using the following module, such as login, dashboard, consumer information, view user logs, print reports, settings, and lastly, evaluate the system in terms of ISO 25010 product quality standard.
The first objective of this project was to develop a Arduino-based system, a web-based system that controls the electric line and notify the specific client for disconnection and reconnection. This platform was designed and developed to eliminate the manual task of the line personnel in disrupting the supply of electricity in a household. The front end of the system was designed using Bootstrap framework, while the back end of the system was designed with a combination of PHP and MySQL. There are two users of the system, the administrator and the sub-administrator.
This figure shows the login page. The page required the user to input two valid information, such as username and password. Users successfully log in into the application by entering their username and password and clicking the button Login. However, if the user forgot their password, they can reset a new one by clicking the Reset Password. Then the page required the user to input the valid username and PIN code in the system. After inputting the username and PIN code, the system automatically generate a new password.
The figure shows the home page of the user. This can be seen by the administrator who has a valid account and successfully logged in. On the home page, the admin can view the different functionalities such as dashboard. The dashboard provides the viewing of the total consumer, the inactive meter, and active meter. Also, the disconnection and reconnection chart. The consumer module where the admin can view the list of the consumers and control the consumer status. Report module where the admin can print and provide the list of report of the client status due for disconnection and reconnection. The user module where the admin can view the sub-administrator of the system and also can add a new sub-administrator who can access the system. The logs module where the admin can view all the activities and sub-administrator activities. And lastly, the setting module where the admin can change the username and password.
The second objective is to develop a prototype that controls the flow of electricity in the targeted household. To answer the objective number 2, the following components were used in this project. First is Arduino Uno R3, Ethernet shield, breadboard 200 points, jumper wires, male to female, male to male, 5 volts 1 channel solid state relay, USB to serial cable, 12 volts DC power adapter with 3-way splitter, 5 volts power supply module, router, contactor, and 5 volts mini fan. This figure shows the wiring diagram of the Arduino-based device controller. The main board of the operation is the Arduino Uno R3 in combination with Ethernet shield. The Ethernet shield serves as a connection between the web application and Arduino device. The 5 volts breadboard acts as a power supply of the relay. The 12 volts DC power adapter with 3-way splitter serves as a power supply of each module. The solid state relay used as a switch to turn on or off the contactor. The 5 volts mini fan serves as an exhaust fan to circulate the air temperature. The contactor serves as a main switch of the electric line that can hold 220 volts.
The figure shows the developed prototype. The ABAX device was built in a utility box with 15.98 cm length by 9.15 cm width and 5.26 cm height. The Arduino Uno with the Ethernet shield and the breadboard with 5 volts power supply module was placed inside the utility box. The junction box at the top of the utility box where the splitter and the 5 volts mini fan was placed. The solid state relay was fixed at the right side of the junction box. By the use of the Arduino IDE, the code of the program was uploaded in the Arduino Uno.
The installation of the device on a household and testing has been conducted last January 17, 2022 at San Mateo, Isabela together with Engineer Aldwin Makatbag, an electrical engineer of Eselco 1 Alicia Isabela. The device installation alongside the fuse to test the functionality of the device and avoid short circuit in case the device doesn't work successful. The testing and installation of the device was successful.
The interface of the Arduino-based alternating current controller system. The implemented system is a responsive web application that can be viewed in different screen size devices. This web application can be viewed by the domain abax.com.
Third objective of the project is to test the following functionalities. First is the login form. The purpose of the login form is for the admin to enter 2 pieces of information. First, a username and then a password in order for the admin to fully access the system.
The main page, which contains different functionalities such as dashboard, consumer, reports, user, logs, and settings. The admin can visualize the data on disconnection and reconnection via chart. The purpose of this form is to allow the administrator to navigate and access all the modules contained therein.
The consumer module in the system. In this module, it allows the administrator to view the list of consumer, which comprise the household number, consumer, details, and status. This serves as the interface of the administrator in editing the content of the database of the system. Any changes in the information in each of the tables are executed in this interface. The form contains 3 command buttons: disconnect or reconnect, edit, delete, and search bar.
The consumer form is adding a new consumer. The form contains 2 buttons. the X button to cancel, and the submit button in order to add a new consumer. The purpose of this form is to allow the administrator to add household number, name, address, email address, CP number for the SMS notification.
The administrator interface in the report of the system. The form contains one drop button, of which the status that the admin can select the disconnect and reconnect, and a calendar button, also search and print buttons. The purpose of this form is to provide a copy of list of consumer with their current status.
The administrator interface in the activity logs of the system. The form contains a search bar. The purpose of this form is for the administrator to view the admin and the user activities in the system. The settings where the administrator can view the account credential. The form contains a submit button. The purpose of this form is for allowing the administrator to change username, password, and a PIN code. The third objective of this project was to evaluate the system using the ISO 25010, the software product quality standard, with 20 evaluators such as IT expert, clients, and electrical engineers. The result of the system evaluation has an overall mean of 4.51 from IT expert, clients, and electrical engineer, with a qualitative rating interpretation of strongly agreed. The conclusion. After the successful development of Arduino-based alternating current controller system, the researcher concluded that the Arduino-based alternating current controller system is developed to help ISELCO 1 in disrupting the supply of electricity through various strategies objective. A developed system can effectively and efficiently manage consumer by controlling the supply of electricity and providing a safe process of disrupting of electricity.
After the development of the system, the researcher conducted security tests to make sure the user is safe while using our system. The researcher checked for the cross-site scripting or XSS and URL manipulation using HTTP methods. Lastly, the researcher also checked the hardware to ensure each consumer is safe when the device is installed in their household. The researcher consulted an electrical engineer for verification and also test the device.
After testing the developed system, the researcher immediately implemented by making a video guide on how to use the system, both in sub-admin and admin role. It was tested and used by a number of users while gathering a feedback and giving them the chance to evaluate the system.
Recommendation. Based on the result of the study, the following are the recommendation additional systems features for future researchers. First is include monitoring module in the system, include daily consumption monitoring module in the device, include an alternative way to access the device such as SMS and internet power line, include an emergency battery.
That would be all.
Thank you.
A
A wonderful day to all of you.